This is coming from the student of Facebook Academy. Your subscription worth more than you might ever think. Please don't forget to subscribe after watching this video.
Greeting of the moment to each and every one of you. I hope you are all staying safe at your respective homes. Today we'll be looking into the structure and properties of alkanoic acids. So these are the key concepts that you have to master. Alkanoic acids belong to a class of organic compound known as carboxylic acids, and carboxylic acids contain the COOH functional group. So COOH is the functional group of carboxylic acids. So whenever you hear carboxylic acid, it's same as alkanoic acids. Like OH is the functional group of alkanols. So alkanoic has its functional group to be COOH. So alkanoic acids are generally organic acids. Like alkanol are organic, something like I can say organic bases, organic alkali, something like that. These are the alkanol. For organic acids are called alkanoic acids, and very long chain carboxylic acids are found in biological system and referred to as fatty acids. So we'll discuss about fatty acids later in another tutorial. And general formula of alkanoic acids is given as this general condensed structural formula is CnH2n plus 1 COOH. You know, COOH is functional group, it must be there. Or you write it RCOOH. Why R? Don't forget, anywhere you see R in organic chemistry, it mostly refers to alkyl group CnH2n plus 1. So, and molecular formula of alkanoic acid is CnH2nO2. So you can sum up the structural formula above, you get we are up at CnH2nO2 for the molecular formula. And how to name alkanoic acids? You have to. The first step is number the longest carbon chain, starting with the carbon atom of the COOH functional group. So you have to. We discuss about this later, sure. But you start your numbering from the carbon atom that is bonded to our COOH functional group. And the second step is name the carbon chain as the alkene. So I mean, you start your numbering from the number that is attached to the COOH functional group. The number of the carbon chain that you are able to number, like if it is 4, that is butan. Okay, so you have to name it as what? Your alkene. Now drop the E from the name of the alkene and add suffix oic, just like we did in the alkanol, where you have to drop the E and write OL. They call it ethanol, butanol, pentanol. Here it will be ethanoic acid, butanoic acid, propanoic acid. You drop E and write OIC, that is oic. So now let's look into the physical properties of alkanoic acids. Alkanoic acids are polar molecules, so they are expected to be more soluble in polar solvents like water and to have higher melting and boiling points than the corresponding alkene. So that the same thing happened to the alkanols too. They have the corresponding alkanol and its what do you call it? Its corresponding alkene. They have different boiling points, and the body and melting point of the alkanoic acids and their corresponding alkene are quite different. While that of alkanoic acids are, higher than that of the corresponding alkene. Now, alkanoic acids are weak acids, so they are expected to display similar physical and chemical properties to other acids. And chemical reaction of alkanoic acids. Alkanoic acid react with a base in neutralization reaction. I've told you this. Alkanoic acid is an acid, but just an organic acid. It's an organic acid. So the reaction between alkanoic acids and some bases to form salt and water is what we call neutralization, just like normal acid and base reaction. And it also reacts with carbonates to produce salt, carbon dioxide and water. So, and it reacts with active metal to produce hydrogen gas. And also it reacts with alkanols, that's alcohol, to produce organic salt. That is, the process is called esterification. Esterification is the process by which by which alkanols and alkanoic acid react together to form organic salt. That's the organic salt is called ester. So if you want to name an alkanoic acid, these are the steps that you have to follow. Number one is you number the longest chain, the longest carbon chain, starting with the carbon atom of the COH functional group. Look at this one now. Look at this one now. If you look at this diagram very well, you can see that the number is from the left here. You have 1, 2, 3, 4, and the first carbon here is attached or bonded to COOH functional group. You can see the double bond that is between the carbon atom and oxygen atom. That is telling you that this is the one that is bonded to the functional group of the alkanoic acid. When you see the the double bond, that is pointing to the carbon that is attached towards the functional group of alkanoic acid. And then you name the, you cannot look at this diagram. The highest number we have for the carbon chain is 4. Then name the carbon chain as the alkane. 4 is butane, that's butane. Then you drop the E of the butane and replace it with what? Suffix oic, that is butanoic acid. Butanoic acid. So
let's talk about the physical properties of alkanoic acids. Alkanoic acids are weak acids and as such are expected to have the following properties. And one, the taste is sour. Normal acids too. See, the taste is sour and it conducts electricity in its solution, and it turns blue litmus paper red. So because alkanoic acids are capable of some dissolution in water, we expect them to display some solubility in water. And alkanoic acids exist as covalent molecular substances. So their melting point and boiling point are expected to be quite low. So let's talk about the melting point and the boiling point of alkanoic acids. So alkanoic acids are polar molecules. That's why they are soluble in water. So we're talking about the hydrogen bond, which can be found between the which can be formed between the alkanoic acid. So alkanoic acid have higher melting point and boiling point than other compound with the same number of carbon atoms. So what this thing is telling you is that it's like we've talked about this when we discussed about alkanol the other time. The major difference why the number the boiling point and melting point of alkanol and alkanoic acid are greater than the boiling point and melting point of their corresponding alkane is that the carbon-carbon chain in alkanes are bound together by weak van der Waals force, while carbon-carbon chain in alkanol and alkanoic acids are bound together by a kind of stronger hydrogen bonds. So we have to get that, please. Likewise, it's happened to alkanol. The melting point and boiling point of alkanoic acid are increased with increasing number of carbon atoms in the carbon-carbon chain. And one thing about the alkanoic acid is that the boiling point of alkanoic acid increased by about 20 degrees centigrade for each carbon atom that's added to the carbon-carbon chain. Now look at this table below. Look at the formic acid, that's metanoic acid, that's having one atom of carbon. It's having a boiling point of 100 degrees centigrade, while acetic acid that's having that's ethanoic acid, that's having two number of carbon atom. It's having its boiling point increased to 180 degrees centigrade. That is about 18 degrees, different from formic acid. Look at the propanoic acid that's having three number of atom carbon. It's having its boiling point increased to 141 degrees centigrade. While butanoic acid, that's butyric acid, with 4 atoms of carbon is having 164 degrees centigrade as its boiling point. Look at pentanoic acid with 5 number of atoms is having boiling point of 186 degrees centigrade. Look at it down to heptanoic acid that's having 7 atoms of carbon you can see that the boiling point has increased to 223 degrees centigrade. And with this, you can verify that the melting point and boiling point of alkanoic acid increases as the number of carbon-carbon chain increases. So get that. So it is important to note that as the carbon chain becomes longer, the intermolecular force of attraction between this carbon chain becomes greater. So the weaker van der Waals force become more significant, and the amount of energy required to separate the molecules so that the liquid will boil becomes greater. So now let's look into the solubility of alkanoic acids in water. Short chain alkanoic acid, that's from methanoic acid to butanoic acids, are very, very soluble in water. They are mixable in water. Understand? As a result of this is because as a result of hydrogen bonding between the OH group of the carboxyl group and water molecule. So, however, after the butanoic acid has the number of carbon atoms in the carbon chain increases, the solubility of the alkanoic acid in water decreases. This is because the weaker intermolecular force of attraction between the hydrocarbon chain becomes more significant as the chain becomes longer. So the ethanoic acid are more attracted to each other than the higher to the polar water molecule. So you have to get that from methanoic acids to butanoic acids, the solubility of alkanoic acid in water is greater. That is the greatest. You can attain the maximum. That is the optimum of solubility of alkanoic acid in water at the pentanoic acid. So the pentanoic acid is you can call it the boundary of where you can attain optimum solubility of alkanoic acid in water. So as the carbon chain increases from hexanoic down, so the solubility decreases. Note that, please. So now let's look into the chemical properties of alkanoic acids. One thing to note is that the alkanoic acids are weak acids because the solution constant of alkanoic acid is small. So all organic acids, either alkanoic acids, are what? Weak acids. Please note that. So, but we should also note that the acidity of carboxylic acids increases with the substitution of higher electronegative atoms such as chlorine in the molecules. So alkanoic acids react with base in neutralization reaction. It reacts with carbonates to produce salt, carbon dioxide, and water. As I said earlier, it reacts with active metal to produce hydrogen gas. Active metal group 1 metal, right? And 2, it reacts with alkanols, that's alcohol, to produce ester in a esterification process. So, and let's look into the alkanoic acid and neutralization reaction. Alkanoic acid are acids. They react with bases to produce a salt and water in a neutralization reaction, right? You can see here that is carboxylic acid. That is reacting with a strong base to give you water. That's metal alkanoate. So one thing here about metal alkanoate is that you name the salt exactly the way you name the inorganic salt, like sodium chloride. You say sodium ethanoate. So that is what this one means, that metal alkanoate. Alkanoate is organic salt, right? So the name of the salt will come first, and water is is also liberated. So please get that. Look at this example now. Ca3COOH plus NaOH. That is when we react this ethanoic acid and sodium hydroxide, it gives you sodium ethanoate and water. So that is a neutralization reaction in the organic chemistry. So the salt produced is the salt of a strong base and weak acid. So the aqueous salt solution produced in the neutralization reaction will be basic. So get that, please.
You should understand what that means, that the salt produced is basic, means that the pH of the salt will be greater than 7. And it's also note that soluble salt of long chain carboxylic acid, that the fatty acid, are called soaps. So if you are asked to define soap in chemistry, say soluble salt of long chain carboxylic acid. That's soap for you. Thank you. For instance, look at this salt and the long chain and steric acid, that's 617H35 COOH and sodium hydroxide react together to give you sodium stearate and water. So that sodium stearate is salt. Please note that. And a reaction between alkanoic acids and carbonate. Alkanoic acid react with carbonate to produce the salt, carbon dioxide gas, and water. Look at it. The acetic acid, that's ethanoic acid, is reacting with sodium carbonate to give you what? Sodium acetate and carbon dioxide gas and water. So that is how the reaction occurs between carbonate and carboxylic acids. So the standard test for carbon dioxide gas, as you all know, is to bubble the gas through lime water to produce a methyl precipitate. So that will confirm that CO2 is formed. Because it is not visible, we can only test its existence. As well, alkanoic acid react with active metals. Don't forget, I told you the other time that active metal a group 1 element, they react with alkanoic acid element to produce a salt and hydrogen gas. Look at the reaction here. A reaction between acetic acid, ethanoic acid, and sodium metal gives you sodium acetate and hydrogen gas. Hydrogen gas is liberated. So you can test for hydrogen by the pop test. You all know the pop test. So and that is how to test for the existence of hydrogen, because hydrogen is not visible. Esterification reaction, let's look into that. Ester are produced in a condensation reaction between an alkanoic acid, that's carboxylic acid, and alkanol. That's the reaction, that is the condensation reaction between alkanol and alkanoic acid to produce organic salt. It's what we call esterification reaction. So look at it now. A condensation reaction is a special type of elimination reaction in which water is the small molecule being eliminated during the reaction. The reaction that produces an ester is known as an esterification reaction. Look at it here. For instance, acetic acid is reacted with methanol to give you methyl acetate and water. So methyl acetate here is an ester. So ester commonly have a fragrant fruity odor. That is our physical property of ester. It has fragrant fruity odors. So you can use your sense of smell to detect the synthesis of an ester. So thank you very much. If you have any question, please ask your question here kindly, please. To receive more of interesting videos like this after minute page is published, don't forget to subscribe on Facebook Academy.